Okay, students, you didn't think I was very clever with my cool Halloween stuff, and you didn't think I was very clever with my music and my skeletons and my cemetery lab. So I'm going to make this crazy video of me at home at night with my hair crazy and everything to show you the population practice packet. I'm in your lab book on pages 6 through, I think it's 12. Yeah, 6 through 12. And I want you to go ahead and open up to those. I'm going to go through this a little bit. It sounds really long because it's that's a lot of pages, 6 pages. But I want to tell you the packet was originally like 9 pages, and I made it smaller and shorter for you. And I noticed when I was going through it to make sure I was good with all the questions, I did notice I have to delete some of them because it didn't make sense, because it's referring back to data that I had deleted. You know, I didn't give you the pages. So I'm going to go through this little packet, make sure you understand everything, and I'll post pictures of it so that you can check your answers and make sure that you really understand how to do this math. This is some of the math that for sure will be on the AP test. Okay, so open up to these pages and I'll explain everything. Okay, so here is page 6, and we already started this, I think, in at least one of my classes, and we went through this table. So just go ahead and make sure you understand all these. This is talking about exponential versus logistic growth and the J curve and the S curves. So just make sure you understand that. If you don't, you probably need to go back and look those up and make sure you understand them, or let's talk about them in class, okay? Okay, so this goes on to it further. This is talking about the exponential model. The exponential model is a J curve graph, okay? And it basically shows unchecked growth, and it shows that the growth of the population is going at biotic potential pretty much, and is not being stopped by carrying capacity. So this would be R selection type graph, and this would be exponential growth, and it would be a J curve. Okay, so I explained that here. And then this just shows you the math of exponential growth. This was actually in the slides that we did as well, so this shouldn't be anything new. And then here I've calculated the 1, 5, and 10 years, okay? And then here we've got some things about the logistic model. The logistic model is an S-curve graph. The logistic model is showing carrying capacity, and it is showing checked growth. So we're not having out of control growth, but we're having limited growth based on carrying capacity. And then I answered these questions here. So hopefully these 2 pages pretty much made sense. It felt like when we did the lab, the bubble lab, we went over that in both classes. So let me know if you have any questions about that, but hopefully that was really understandable. Okay, then we went over here, and on the next page, page 8, this is talking about reproductive strategies and R selected versus K selective. What are advantages and disadvantages? R strategist versus K strategist. I wrote down my answers. You may have already written down some answers, and they may have been different than mine, but still true. So just make sure that you've got the general idea. And again, R selected, K selected, showing you the growth patterns, okay, and some answers there. So again, still the same thing. I think that we talked about this in class, and hopefully this made sense. But go to the pictures that I posted. I'm going to post pictures of this so you can check your answers, and if you were confused, you can check my answers and see if that helps you. Okay, this page right here is just the equations. You don't have to do anything here. These are just equations. By the way, it does say here, complete the following problems neatly. Calculators are not allowed. That is not true. They are now allowing calculators on the AP exam. So that is old news. This year they will allow calculators. Okay, now comes to these calculations. This is probably stuff that's more new. Okay, and this stuff is using these equations for the most part. Most everything is right here. There's a couple things that aren't, and I'll tell you what those are. But if you run to a problem, then turn over here to page 9 and get the equation for it. Okay, but again, I will just post pictures of this so you can do all the calculations and check if you need help, okay? Over here, it's the same thing. You're going to use the calculations over here, or the equations over here, and you're going to be able to calculate all of this data right here, okay? And then right here, It was really easy to calculate these, okay? We're just going to subtract the birth rate from the death rate, divide by 10, or excuse me, multiply by 10, right? No, divide by 10, we're right here. Births, subtract deaths, divide by 10, and that's gonna give us the rate percentage, and that's how we did this table right here, okay? So use that equation, and that will help you do the table. Okay, this is the part I wanted to be sure to talk to you about, because this is the part that doesn't make sense. This is where there was like 2 more pages in between here, and I deleted them, 3 more pages. So they're gonna ask you some questions that don't make sense, and so I wanted to make sure that this was explained. So right here is the human population growth from year 1 BC or AD till 1990. And it says in Microsoft Excel, plot the data below in a line graph. I don't want you to spend the time doing that because it takes too long. So I did it for you. Okay, so attached to this assignment is going to be a Google Sheets, and the Google Sheets has this all typed in for you, and it has the graph already made for you. So all you need to do is just draw it. I'm not gonna make you print it and glue it in here. You don't have to do that, just draw it here. And I didn't even write the times. I just wrote this is time and this is population, okay? Just so you can see that J curve. I'm trying to make this easier for you and less time consuming. So hopefully that helps. Okay, now to the part where it got a little confusing. Some of the equations on this part right here are not on here, and they're not in the packet because, again, it was on those pages that I deleted. So make sure that you go through these and you understand these. It says use your graph to determine the doubling times for the human population. Okay, so when you go into the graph, you're going to see that from year 1 to year 1700 AD is 1700 years, and that's when it doubled. And you don't even really have to go into the graph. You can just look here. Year 1 was 250 million. So the doubling would be 500 million. So if you go up here, you can see 500 million is somewhere in here, somewhere in between 1650 and 1750. So around 1700 is when we hit the doubling time. So it took about 1700 years for the population to double. So I just wrote 1700 years here. So that's what you're gonna do with that. Okay, here, using the most recent growth rate, and on your graph, and extend your graph to the year 2010. Just make it a dashed line. So this is how I did that. I did 5.3 billion people, that's this right here, 5.3 billion or 5,300 million, same thing, in 1990, and then I did 5.85 billion in 1985. So that's that number right here. Okay, and I subtracted those and I divided by 5 years. So I took the population change and divided by the time, and that told me the population was increasing by 90 million per year. Okay, and then if you take that 90 million per year and you divide it by the final population, which is 5,300 million or 5.3 billion, then the growth rate is this, 0.01698. This is the growth rate of humans in the 90s, 80s and 90s, okay? All right, so then here it says, what do you estimate the human population will be in that year? So what do you estimate in 2010 the human population will be based on this data? So to do that, I used the NERT or PERT equation. So the population over time is going to be equal to the original population times E, and I didn't really write this very good, did I? E to the RT power, okay? Those should be exponents. So the population over time is equal to the original population, 5.3 billion, and times E to the birth rate. Remember, we got the growth rate right here. Okay, so here's the growth rate times 20, because from 1990 to 2010 is 20 years. And I calculated all that out, and I got 7.443 billion people are predicted by this equation in 2010. Then it asked me to look up what the actual 2010 population was, and the actual 2010 population was actually 6.9 billion. So the equation wasn't perfectly right. We must have slowed down in our reproduction just a little bit, because we only had 6.9 billion in the 20 years, and it should have been 7.4 billion. So the growth rate must have gone down just a little bit in humans in that 20-year period. Okay, so it was close-ish, but it is a little bit different. Okay, number 52. Using the doubling equation, find the doubling time for the current population based on the rate of growth. And I asked you to do from 1985 because we already found that. I didn't want you to have to calculate it again. So from 1985 to 1990, this is the growth rate. So I didn't want you to have to find it again, so I just did that one. From 1985 to 1990, in what year will the present population double? So we're going to use that doubling rate, that rule of 70s. So we did 0.7 divided by the rate. 0.7 divided by the rate equals 41.2 years. So if the population kept growing at the same rate that it did up here, then in 41 years, we would double the population. Okay? All right, then 53 and 54 are asking questions about reindeer, and those are the pages I deleted. So just cross them out. Okay. Number 55, it just says what might happen if population of humans continue at the present growth rate. We don't know. Could hit carrying capacity of Earth. We don't know. What methods could be used to reduce growth rate? Education, especially of women. Access to birth control for couples. Suggest several problems in your country that are related to human population. These are just some of them. You could come up with your own. I'm fine with that. Okay, so hopefully that helps make this last page make sense, because I did change some things and that last page wouldn't make sense without that. Let me know if you have any questions. I'm going to take pictures of this and post it, and I will post the Google Sheets that shows that graph right there, and hopefully that makes sense. And this is really good practice for you to make sure you understand how to calculate these population math problems. Okay, thanks guys. We'll see ya.